Hi there. After understanding the concept of delay in the benefits of a project, which was done for the mutually exclusive projects, now we are going to consider the time dimension in a different way, where the whole project is delayed, and then we consider that how much delay is useful or not. So now the benefits will not be the only thing to shift. Instead, the net benefits, that is the difference of the benefits and the cost, that will shift. While the decision makers, they have to decide about the optimal time for starting the project. This becomes a concern for the cost benefit analysts, that they have to suggest the most suitable time so that the NPV gets maximized and the benefits, they are maximized as well. So we can start the project not just from the current year, instead any other time period in the future. There are two ways actually to judge that which one of the years is suitable. One is the first year return method, other is the usual NPV method. Here we must remember that first year return method is not the perfect method. Instead, we will depend upon the NPV method. This is just a complementary method that can help us to make a good guess about which one of the projects is the suitable one when it comes to the beginning of the project. The formula is here. We have to calculate a certain ratio, first year return ratio, and in this we will write the first positive net benefit in the numerator, and then we will place the absolute value of the sum of the negative net benefits, and then we'll multiply it, so that ratio will become some sort of percentage. Now the conditions for this is that it is applicable where the time dependent benefits occur and not the project benefits, project dependent. This means that the benefits and the costs, they will change as the time changes, and they are not only dependent upon the project. So the time factor is crucial, in simple words, in this situation. Secondly, when it comes to the tail end effects, they are negligible. It means that the costs and the benefits at the end of the project, they are not that much, or they are discounted substantially so that they decline. So these are the two conditions that make this method more reliable, that is this method, first year return method. Then we also have the NPV method, which is very much reliable, and we have done it many times before. Let's focus on one of the examples. Here we have a project that we want to decide the most suitable time for years, and then the serial number for time, that is 1, 2, 3 up to 32 years, or the year would be 2053. So these are various possibilities of starting the project. That is, we can start it from 2022, or the next year, that is 2023, or the following year, that is 2024, and so on up to 2029. So we did the experiment till 2029. We can do this for remaining years as well, but for the sake of simplicity and brevity, we have chosen only these years. So you can see that the first two values are the construction cost or the initial cost. This is why the net benefits are negative in all of these possibilities, and they are the same. These values, they are the same because they are showing the beginning of the project, and that is the same project, and we are talking about the construction cost. Then the first positive net benefit occur, which is 61 in this case, 67 in that case, and 73, 79, and so on. So you see that it is increasing as we are delaying the project. The first positive net benefit, it is increasing. Then we come to the remaining pattern, and before we go ahead, just a reminder that these are the three values that we can use for the first year return method. That is, in the numerator we had the first positive net benefit, and in the denominator the absolute value of the sum of these negative net benefits. These will be the three for the other possibility, and then this one, this triad of the values, and this triad of the values, and so on. So let's focus on the other net benefits. There's a certain pattern that from the year 2043 and 2052, the net benefits, they are remaining the same. They are not changing. So this is one pattern, which will be logical and relevant when it comes to the NPV method. Otherwise, in the first year return method, it will not be meaningful because these values will not be used. That is the values in the yellow color. So let's start our calculations. So this is the table of calculations. Again, the same set of years, time, discounting factor is now brought. It was not there before. And 2000, the first possibility, starting now and starting after 1 year, starting after 2 years. These are after 2 years, and then after 3 years, after 4 years. As you can see, the first 4 years are having blank values, after 5 years, after 6 years. So there are, there's another possibility of delaying it for 7 years. So there are a number of possibilities that we have, 2022 and then 2023 up to 2029. We have the discounting factor. So under 2022, we have net benefits that are undiscounted and discounted net benefits. Multiplying the discounting factor with the net benefits will give us this value. And for this value, for example, minus 241.5, we have multiplied the net benefit with the respective discounting factor. So in this way, all of these values are calculated. You can see the yellow color showing those fixed values, and we can calculate these values and then we can find the results. Now the very first thing is the first year return method for 2022, and then it is 8, and then it increases up to 8.8 and 9.6, 10.5, 11.4. Now it is 12.4. This is the point of attention because this is the first time that the first year return method is giving us a value which is greater than the opportunity cost of capital, because the opportunity cost of capital is 12%. Till this year, the discounting factor was used to find out the NPV, and also the first year return method, that is the year 2026. But the answer was less than the opportunity cost of the capital, which is assumed to be 12%. But in this year, that is in the year 2027, it is greater than the 12% opportunity cost of capital. So this is that year in which we should start the project as per the first year return method. Here the first year return method is giving us higher values, but these are of no use because this is the very first value which is greater than the opportunity cost of capital. So this is the criterion of using first year return method. However, we know that we can also calculate the NPVs, IRR and NKRs for all of these projects. So NPV, here you can see it is increasing with every new possibility, and it increases and it reaches 300 here and then starts to decline again. So clearly this is the year which seems to be the most suitable for undertaking the project, and again it is the year 2027. So this is the year that should be considered for the beginning of the project. IRR, on the other hand, it's having an increasing value throughout, and it's not highlighting any specific year, and it will continue to increase as we go ahead. Again, NKR is also having an increasing trend, and it is continuing. So this means that the value of IRR and NKR are not going to give us the correct options when it comes to the timing of a project. So year 2027 is now suitable. Here we have made a summary of years, first year return method, NPV criterion, and the IRR criterion and NKR. So at in 2022 it was 8%, and that's where it has crossed the opportunity cost of capital, that is 12, so it becomes 12.4. And again NPV is also the highest in this case. IRR and NKR give us controversial results, so we stick to the NPV and FYR. Here a graph is made and you can see that NPVs are plotted on y-axis and the various time options on x-axis. The NPV is increasing as we delay the project, but 2027 is that year in which the NPV is the highest, and then it starts to decline again. So we go for the 2027 year to undertake this project. So in this way we have understood the timing of the delay in the project, the ideal time in which we can undertake the project. This is that calculation table is quite large, and this is the table in which we enter the various options of time, that is the delay in the project. And this was the explanation of this method. Either by NPV or FYR we can find out the optimal timing for beginning a certain project. Thank you.